I'm Anil Kumar. Welcome to my series with Emmy. We have taken many challenging questions from past test papers. Here is another one. This deals with combination of logarithms with quadratic equation. We'll look into how do we solve such equations, and using derivatives, how could we find the turning points or the local maximum and minimum. Hi, Amy. How are you doing?
Hi, sir. Yeah, I'm good, thank you. How are you?
Very good. Very good. Well, you have shared some questions which you don't understand about logarithms and exponential. So, what is the difficulty you are facing with logarithms and exponential functions, Amy?
Um, I feel like I don't know if I've actually learned this. That's the thing in like class, but when differentiating like the exponentials, the ln x, and making it 1 over x and things like that, I'm just getting a bit confused. And there was a question where I saw like the quadratic in front. So let's say you have a quadratic and you say e to the power of minus x, and they're saying differentiate it. So I thought you just take the -1 times the quadratic, and then the exponential e to the power of minus x stays the same, because when you differentiate that, it is the same. But it wasn't. It was like they differentiated the quadratic and then subtracted it with something else.
Oh, it's too complex. Can you share that
Okay.
question?
I don't know if I've learned. Yeah, have I even learned how to do that, or am I just
I don't
going
know.
on?
Let's see the question and then we'll decide. Okay. So,
Okay.
why don't you share the question? Then we'll discuss all this. It seems to be really complicated, whatever you're saying.
Okay. All right. Yeah, the internet is being slow again, but I will click on it. Pretty sure it's this one. It's on the physics maths tutor questions.
Okay.
So get that up.
So you look into wide variety of questions available on internet. You really
I do, like everything. There is exam solution bank, there's physics maths, there's just some random documents that students have just put on, because I have to get the variety, you know, because they wouldn't go for like these specific ones.
Okay.
This question.
That is.
So yeah. So it was this question, part C, when they said do it.
Okay. So can you please read the question? Let me understand what the question is, and then we'll figure it out. Yeah.
Okay. So the diagram above shows a sketch of the curve C with the equation y equals 2x squared minus 5x plus 2 times e to the power of minus x. So yeah, part A and B were fairly straightforward. It's just like finding the coordinates of the point where C crosses the y-axis. So that would be 2, 0, 2, yeah.
E to the power minus x. Okay, that's your equation. Perfect. Find the coordinates of the point where C crosses y-axis. So y-axis means this point. X is 0. So let's put 0 here. So we get this, and we get 2 here. And e to the power of 0 will be 1. E. Anything to the power of 0 is 1. So we get 2 there, right? So this point is 2, correct?
Yeah.
Now, part B is what? Show that C crosses x-axis at x equals to 2, and find the x coordinate of other point where C crosses x-axis. So basically, we have to find these two, right? So you solve that also. That means you equated 0. Let me just, for the benefit of others.
I just factorized the quadratic.
Okay. So yes, tell me what is the factored form of this?
2x minus 2 and 2x minus 1. Oh, sorry, 2x minus 1.
Okay. Yeah. 2x minus 1 times x
and
minus
x, yeah.
Times e to the power of minus x. So definitely you get x equals to 2 and you get x equals to half, right? So those are your 2 points, correct?
Yep.
Very good. Now what is part C?
Find the derivative, first derivative.
First. That is where you're getting stuck. Find the derivative.
Yes.
So we have
part of it, not
Okay.
the other part.
So y equals to 2x squared minus 5x plus 2 e to the power of minus x. So you'll apply the product rule, right? You want dy dx. Okay. So what is the derivative of the first part? 4x minus 5 times e to the power of minus x plus. So we are applying the product rule, correct? So you'll keep this term as such, which is 2x squared minus 5x plus 2. And what is the derivative of e to the power of minus x? E to the power of minus x times minus 1, right? So let me write minus 1 for now here, right? So that is your derivative, correct?
Oh, so I didn't know it was a product rule.
Yeah, product rule. You can take e to the power of minus x common, correct? E to the power of minus x common. And what do you get here? You get 4x minus 5 plus all this. No, it is negative because this is negative, right? So minus 2x squared plus 5x. Change all the signs, correct? Simplify this. So we get what? Minus 2x squared. 4x and 5x is 9x. And minus 5 and minus 2 is minus 7.
Minus 7. Yeah.
You could write minus outside and make that the other way. You could do that. Like minus e to the power of minus x. And you can write here 2x squared minus 9x plus 7. Either way, it works. So that becomes the derivative of this particular function. Is that clear to you?
Yeah.
What is the next part?
Okay. So part D is hence find the exact coordinates of the turning points of C.
Yeah, turning point means derivative is 0, correct?
Yeah, so we just need to make that equal to 0.
The turning point is that dy dx equals to 0.
Yeah.
So you have this term which is, so that means basically e to the power of x or minus x will never be 0, right? But this could be 0, correct?
So we just need to solve.
We solve for this. 2x squared minus 9x plus 7 equals to 0. Again, factor.
So I can do on my calculator.
7 times 2, right? So 2x squared minus
2x.
7x minus 2x plus 7 equals to 0. You can take x common, right? So you get 2 minus 2x minus 7, and you get minus 2x minus 7. You can also directly factor and get the answer. 2x minus 7, x minus 1, 0. So you got turning points at x equals to 7 by 2 and x equals to 1. Correct?
Yeah.
So find exact coordinates. When they say exact coordinates, you have to find the y value. Correct? Plug it in. Yeah, don't miss that part. Otherwise, you lose. Oh, it's 12 marks. You lose 5 marks, 2.5 you lose, right? So plug it in and calculate. Is that clear to you? So find y value for 7 by 2, that is 3.5. And also the y value for 1. Is that okay?
When you plug it in, we're plugging it into the 2x squared minus 9x plus 7 equation.
Yes, right? Originally.
Oh, into the original equation.
Yes. So that is your original function, right?
So if you do e to the power of 1, when you get like a decimal value or something.
Whatever you get, you write down.
Oh, okay.
Yeah.
No, because when you get, when I've always noticed it with like, especially me when I'm in a test, when it says exact coordinates, I always feel like exact means like, full values.
Yeah. So when they say exact coordinates, when you work it out, you might use square, something like just calculate.
Okay.
Yeah. So you write divide by e. You write when you do 1 here, so you will have a value for the quadratic expression for 1, correct? 2.
So I got minus 1.
Minus 5, right? So one of the value is minus 5 over e. You see that? That will be one value. Is that clear?
Wait, so you subbed in 1 and you got 2 minus 5 plus 2, which is minus 1.
Minus 3. 2 and 2 cancel? Oh, minus 1. Oh, sorry.
Wait, is it just 1? Oh.
1. Minus 1.
Yeah.
Minus 1 over e, you write. Don't divide by e. E. Put the power
of... you're doing 1 over e to the power of x.
Yeah, yeah.
Yeah. Oh, okay.
-1.
So
Oh, yeah, that
minus
much.
1 over e.
So e in the denominator.
Oh, so that's the value they want to see, not like the decimal value.
No, no, no. That's the value.
Okay. Got it. Yeah.
But you could get sometimes square, not in this particular case. So 7/2, when you plug it in, whatever fraction you get, right, that fraction is such.
Okay.
And e to the power of -7 over 2. So is
Yeah.
that clear to you?
Very clear. Thank you, sir.
So we'll end the class here. I hope you have understood. So can you summarize your learning? I'll clear the screen and then we'll stop sharing.
Yes. So yeah, I think the main concept of this question was like the whole product rule and the laws of logs, trying to like get it back into my head. So yeah, when you saw the quadratic times, because you know you don't usually see that, it just kind of like already flusters you. So just kind of breaking it up and seeing as that quadratic is multiplied by the exponent, so it's using the product rule, and then you differentiate both. But when you add them, like do it really carefully, because the e to the power of minus x means that you're timesing that whole thing by -1. So everything, all the signs would switch. But apart from that, yeah, it's simple, like quadratic factorizing and straightforward. Yeah, and then we learned about when it says exact coordinates, you have to find the y values as well.
Y value also, correct.
Yeah, not just the x. Yeah.
Okay, then. I hope that helps, Amy.
It was super helpful, sir.
We'll
Thank you so much.
Okay, thanks.
I really appreciate it. Bye, sir.
My pleasure.